Hi friends, I am B. Ramesh from St. Peter's Engineering College. Today I am going to explain you a light emitting diode, which is in your first unit diode applications. Uh, See, light emitting diode. Light emitting diode we are shortly we are calling LEDs you can say. Okay, so this LED converts electrical energy into uh, light energy. So generally the LEDs in a optical diode which emits light when forward biased by a phenomena called electroluminescence. So this diode operates in a LED forward bias. So photodiode operates in reverse bias. Okay. So this diode operates in a forward bias. So how much voltage? Suppose the bias voltage based on the bias voltage directly proportional to current, diode current, LED current. Okay. So generally this LED there are different kinds of LEDs will be there, infrared and uh, red LED, blue LED, green LED. Okay, so generally we are supposed to manufacturing the materials this device by using the gallium arsenic, gallium arsenide and gallium arsenide phosphide or gallium phosphide. These are the mixtures of element gallium arsenide and gallium arsenide phosphate. Okay, so generally gallium arsenide we are using for a red LED and gallium phosphide we are using for green and gallium phosphide we are using for blue. So among this three types of LEDs, the forbidden gap more for blue color LED. It require more suppose bias voltage to glow the blue LED. Okay, and red LED having the forbidden gap between valence band and conduction band 1.8 electrovolts. Okay, so forbidden gap for silicon 1.21 electrovolts and germanium 1.7 0.7 electrovolts. Okay, to jump the charge carriers from valence band to conduction band, it required that much energy. Okay, that is representing the energy gap. Okay, so the symbol for LED, the arrow mark is outside. When you see the photodiode, arrow mark is inside on the suppose depletion layer. But here LED arrow mark is outside. That means this diode converting electrical energy into light energy. Okay, so the working of this LED, when an LED is forward biased, the electrons and holes moves towards the junction and a recombination takes place. Recombination takes place. As a result of recombination, the electrons lying in the conduction band of N region fall into the hole fall into the holes lying in the valency band of the P region. That means when you apply the forward bias to LED, the holes start from the jump from the valency band to conduction band, and electrons re retransmitted from the conduction band to uh, valency band. In that movement, when the electrons jumping from the conduction band to valency band, the recombination is takes place in the form of photons. That means in the form of light energy, in the form of light. So we know the energy is equal to Planck constant and photons. Okay, so photons mu is equal to uh, energy by Planck constant. Okay, so based on that equation, so the LED will be glow. Okay, so the difference of energy between the conduction band and valency band is rated in the form of light energy. Okay, so the energy released in the form of light depends on the energy corresponding to the forbidden gap. This determines the wavelength of the uh, emitted light. The wavelength determines the color of the light and also determines whether the light is visible or invisible. Okay, so lights is depends on the, but suppose applied energy. Okay, if frequency is low, if energy is low, frequency is low. Okay, if frequency Planck is constant. Okay, based on the applied energy, that much light will be released. So there are the colors, the color of the emitted light depend on the type of material used. Gallium arsenide, infrared radiation. Okay, IR sensors, IR you can use radiation. And gallium phosphide we are using for red or green. Gallium arsenide phosphide we are using for red or yellow. Okay, so here for yellow color, it required a more it has more energy gap. Okay, greater than the red LED energy gap. Okay, the brightness of the emitted light is directly proportional to the forward bias current. Okay, so brightness, how much, suppose applied the bias voltage, so based on that bias voltage, and this one, and based on that bias voltage, your light will be glow. Okay, so first uh, see here the uh, output characteristics of LED. So generally so we have the PN junction diode characteristic, PN junction like this. So this one is a forward bias and this one is negative, is connected to the, this is a P region and this one is the N region. So positive bias and negative bias. So when you apply the bias voltage, so this is a variable receive voltage. When you apply the forward bias, so in P region first starts the recombination by using the minority charge carriers. So in this P region minority electrons, so electrons jump from the P region to N region, and N region having a hole. Okay, N region having the minority carriers holes. So this recombination takes place, and that will release the photon. And similarly the holes moving from the P region to N region, and electrons moving from the N region to P region. So here the recombination takes place, and that will release the energy, so in the form of a photon, in the form of photon. So you can observe the process of luminance. So holes, valence band holes are jumping from the valence band to conduction band, and the conduction band having the electrons. So electrons retransmitted from the valence band to conduction band. When electrons are retransmitted from the conduction band to valence band, so in this gap, so recombination is takes place, and that will release the energy, emitted the energy in the form of light. Okay, so this is called this is a working of uh, working principle of LED. You can observe uh, so advantages of LEDs are small in size. So to glow the LED, it require 4 volts. Some LEDs require 1.7 volts, 1.8 volts. Okay, maximum cutoff, we can say the cutoff voltage. Okay, so we know the formula for, suppose energy is equal to H mu. Okay, H mu E is applied energy, and H is a Planck constant, and mu is the frequency. So mu representing the frequency. If frequency is low, energy is low, frequency is low. So based on this process, mu is equal to E by H. Okay, so energy increases, the photon this frequency increases, and light brightness is also increases. Okay, so advantages of LED. Advantages of LED. LEDs are small in size. LEDs are fast operating devices. LEDs are lightweight and available in various colors. LEDs has long life, and LEDs are cheap and ready to available. LEDs are easy to interface with various other electronic circuits. Okay, so the result is depends on LED. Any if the device is working, that is shows by the LED. So disadvantages of LED: need a large power for the operation. So energy gap is more, means we must apply the high voltage to operate the LED. The characteristics are affected by the temperature. So very careful when you suppose connect the LED. It cannot suppose operates in reverse bias. Okay, because the reverse bias breakdown voltage for this LED is 5 volts. If you apply the more than 5 volts, the large current flow in LED, and the LED will be burn out. Okay, so these precautions must be take care, and very careful to suppose based on polarities apply the forward bias voltage only. So this is the operation of LED, and working principle, and advantages and disadvantages. Application of LED. LEDs are used in all kind of visible displays, that is 7 segment displays and alpha numerical displays. Such displays are commonly used in multimeters, calculator, watches, etc. LEDs are also used in optical devices such as auto couplers. They are also used in burglar alarm systems. Okay, so this is the LED's advantage, disadvantage, working principle, and applications. If you have any doubts, you can comment. I will answer for your queries. Thank you.